Hello everyone, in this video we are going to discuss MATLAB program to calculate the sag of transmission line for when the poles are at equal heights and when the poles are at unequal heights. Especially in this program we are going to discuss about the MATLAB program when the poles are at equal heights. Let us consider a conductor or a transmission line between 2 points or two poles A and B which are at equal heights, and the lowest point on the conductor being the O, and the length of the span is taken as L, where the weight per unit length of a conductor is taken as W, and the tension on the lowest point of the conductor O is taken as the T. And the force acting on the lowest point of the conductor O is of two types. One is W times X, where X is the distance between the point of origin O, or the lowest point on the conductor O, and the midpoint between the point O and point B. And the other one is the tension T acting at point O. And from this, the sag of the transmission line is given as S is equal to W times L square divided by 8T, where T is the tension on the conductor and it is given by the ultimate ratio of ultimate strength to the safety factor. And the derivation for the sag will be discussed on another video, and here we are into the programming part of the sag of a transmission line when the poles are at equal heights. With these equations, sag is equal to WL square divided by 8T, and the tension on the conductor as ultimate strength to the safety factor. Let us start writing the program in the MATLAB environment, where we are going to start the program with CLC, where CLC is to clear the console, and clear all is used to remove the items from the workspace and free up space in the memory of the system. Now let us start with the inputs. L is equal to input enter length of the span, length of the span. Next one is W input enter weight of the conductor per unit length. And U input enter ultimate strength, and S input enter safety factor. Here column is it. And the sag is calculated as sag is equal to, we have a formula W into L square divided by 8T. W is taken from the input, and L is taken from the input, and T is the unknown parameter, and we need to calculate T. T is equal to the ratio of ultimate strength to the safety factor, U by S. Now if you run this program, in the command window we get the output as the first input. Input enter the length of the span. Here the enter the length of the span, and it is has to be some value. Let us consider a problem where a 132 kV transmission line with the weight of the conductor as 680 kg per kilometer, and the length of the span as 260 meter, and the ultimate strength is 3100 kg with a safety factor of 2. These are the inputs, where the weight of the conductor is given as 680 kg per kilometer, and we need to convert it into per unit length, and it is converted as a 680 by 1000, and it is given as 0.68. Now with these inputs, let us enter the length of the span as 260 meters enter the weight of the conductor per unit length is 0.68680 kg per kilometer is now converted into per unit length 0.68, and the ultimate strength is 3100 kg, and the safety factor is 2. Now we got the tension on the conductor as 1550 kg and sag as 3.7071. And here if you look at this, the working tension as 1550 kg and the sag as 3.7 meter. And here if you look at this program, the output is in the second line, T is equal to, and the output is coming at the next line, and also the sag also, the output is coming at the next line. So for that we can mark it on a single line using fprintf command. Fprintf sag is equal to percentage f comma sag, and fprintf tension is equal to percentage f t. And if we run this program again, here in the command window we get enter the length of the span, that is 260 meter, weight per unit length is 0.68, ultimate strength is 3100 kg, and safety factor is 2. And here we can see the sag is 3.7079 and tension is 1550 kg, and now it is coming in the single line, and we need it to be in the separate line. So for that we can use after percentage f backslash n, that's a new line command, here also backslash n, and if we run it again, length of the span is 260, weight per unit length is 0.68, ultimate strength is 3100, safety factor is 2. Now here we got the sag as 3.707097 and tension as 1550. And if you don't want the decimal values, like here in the output solution, here we are having sag as 3.7 meter and tension as 1550 kg. And if you want only one decimal for sag, here we can change in the program as percentage. For sag it is 1.1. After decimal we need only one value to be printed, 1.1. And for tension we don't need any values after decimal, we can mark it as 1.0. If we run it again, the same inputs, length of the span is 260, 0.68 as the weight of the conductor per unit length, ultimate strength is 3100, safety factor is 2, and here the value of sag is 3.7 and the tension is 1550 kg. And the exact value of the sag is here 3.7071 and it is in the workspace, and the tension is 1550. If we want the entire value to be printed here, we don't need 1.1 or 1.0. If you want any exact values after decimal, you can use 1.1 or 1.2 like that, and the actual value will be displayed in the workspace. Hope you people understood the program, and if you have any doubts, please do comment below. We'll be connected. Thank you.